Can everyone see my screen? And everyone, am I audible?
Yes, sir.
Yes,
Okay. So once again, welcome to the problem solving session. So this week I'm going to discuss the assignment 4. So this is the course called Analytical Chemistry, which is taken by Professor Devasis Ray from IIT Kharagpur. And myself, Satyaprakash Yadav. I am a PMRF scholar from August 2020 batch to now. I am working with Professor Satish Patil and in the SSU department, Indian Institute of Science. So this is again a 12-week course. So we have already covered three weeks. In the first week, we have seen the chemical and material analysis method. In the week 2, we have seen the role of analytical chemistry and techniques. And in week 3, we have seen the chemical equilibria and what is the basis of the chemical equilibria in the chemical analysis. And in week 4 and 5, we are going to see the spectrochemical methods. So in this week 4, whatever you have seen, I will just summarize. Sorry, this is week 4. So this is week 4. So in this, basically, in the first, you have seen that. So in this lecture number first, we have seen the different titrometric methods. So in this, what are the important thing is that first we have to see what are the equilibrium process involved and its pH changes. Then you have to assign the equilibrium to the different point of titration curve. That is the second point. Then we have to see the pKa value and equivalence point. And finally, we have to choose the indicator which has the different color in the different pKa range. So this is from the lecture number 16. And if you have seen that lecture number 17, there professor has basically discussed about the acid base titration. So he has taken strong base, strong acid, weak base, a weak acid, strong base, and weak acid, weak base. So he has shown you the different types of acid base titration. And in lecture number 18, basically he has shown what is the region behind the color. So in this you have learned the what is the absorption and what is the complementary color, and if some compound is absorbing some wavelength, what color it will show, that complementary color. You have seen that circle. Okay, so in this basically you have seen the what is the region behind color and what is the, if some compound is absorbing one wavelength range, so it will complementary color it will show. So this concept you have seen. And in lecture number 19, basically you have seen the what are the pK value and pH ranges of the indicator. So once you are going to do some titration, it is very important to know what is the pK value of indicator, in what pH range we can use the indicator. And suppose I'm going to do one titration, so how I will find out that which indicator is the suitable indicator. So these are the things you have already came across in the lecture number 19. And in lecture number 20, you have basically see the like what is the region behind this color and absorption of electromagnetic radiation, and we have introduced it to the instrumental methods of analysis. So there you have seen that aluminum complex, iron complex, and all others metals, what are the ligands we used, why they show the color. So basically these things you have seen in the lecture number 20. So on these 5 lectures, I'm going to solve one previous year assignment. So sorry, I think everywhere it is assignment number 3 is written, so I have to change it to assignment number 4. So this, so first question is, what is the pH range of the blood? So option A is the 2.33 to 3.50. Option B is 7.35 to 7.45. Option C is 8.46 to 8.56. And option D is 9.23 to 9.30. So I will ask that anyone can write that answer. What is the answer for this? Okay. So Swaroop Srinivasan is saying that option B. Okay. Okay. Yeah. So most of the people is right. The answer is B. So the now the question I will explain how to go through why this is the only pH is required for the human blood. So first of all, you can see some range like 7.35 to 7.45 or 8.46 to 8.5. You have seen some kind of point 0.1 pH difference. So this is some kind of uh, like resist to the pH change. Like this will be the pH range in which it will. So basically the concept of buffer came, right? So here we basically see the option is B, correct? So human blood basically the here it's a concept of buffer is there. So now the question is like why 7.3 to 7.45 pH only? So basically the all the whatever the enzyme is there in the blood like hemoglobin and all whatever enzyme is there. So I'm a not biologist. So whatever enzyme is there in the blood, they survive only in the definite pH range, which is suitable like which is 7.4 plus minus 0.05. So basically it will come to 7.35 to 7.45. Now the question is from where that concept of buffer is come. So basically in the human blood, this H2CO3 which is carbonic acid and HCO3 minus. This is bicarbonate ion. So these two are found in the plasma of the blood part. So basically this is the required mechanism which maintain the pH like between 7.35 to 45. So if something abruptly changing like acidolysis or alkylolysis is happening, which will ultimately decrease the uh, on like on acidolysis or alkylolysis, right? So what will it will decrease the effectiveness of enzyme, right? So which is called the denaturation. Denaturation, right? And this is irreversible process. So if a pH is not maintained in the like range 7.35 to 7.45, if pH is abruptly changing, like it is going beyond 7.45, abruptly are going down, that is if it is going down means acidolysis is happening or alkylolysis is happening. So what will happen? This will decrease the effectiveness of enzyme, which process is called denaturation, and it is irreversible, which will ultimately lead to the death. And other way, if you want to if someone is from the biological background, he can easily tell that this option is B. How? Because most of the biological sample we keep in the phosphate buffer cell, right? This is called PBS, right? Which pH is around 7.4. So he can easily see that the okay the option is B, because most of the biological sample most of the amino acid and natural protein we are storing in the particular pH. is 7.4. So now, like this concept is clear. Why the answer is B for this question number one? Can anyone write in the chat box? Just okay. Thank you. Now this is so the question
Sir,
number is yes.
sir, we have done this in the assignment question. Last class we have.
Yeah, I know because that Subhankar is also my friend only. But whatever that we got the uh, notification from the this IIT Madras, they said that
Yes.
same assignment you have to go through.
Last class we have discussed all these things.
Yeah, then like if you are liking, you are welcome to be here. Otherwise, like you can see that how people are approaching. You are like fine. You can like leave. That's only up because whatever notification we have gone, we can go through only that. We can't
Okay,
make
sir.
our new question and all.
How many questions we have today? We have
We are going to the 10 question. 10
ten.
question.
Okay.
Okay.
Thank you.
Uh, So which pair can make buffer solution among the following? So any guesses like which pair can act as a buffer solution? Okay. The option is C. Okay. Sweta is saying option C. Anyone else is there who has different answer? Okay. So the answer is correct. So now we have to go through the logical way, like why the option C only is the correct answer. Like it is suppose we are taking a big acid. So I'm taking big acid as the CH3, big acid and big base, strong acid and strong base. You can take that CH3, COOH, and a big acid you can take like. Any weak acid can take strong acid like HCl and NaOH we can take, right? And option C is that a weak acid and its conjugate base. So suppose we have a weak acid called CH3 COOH, that is acetic acid, and it conjugate base. So I have told already how we can make that a conjugate base. So conjugate base basically we can take as a CH3 COO minus. So basically you can say that either you can take weak acid and it's a salt and it's a salts. So basically we can take sodium salt or any other salt. Right. Now question is that how it will resist the change in the pH. So suppose we have taken that C. So we have taken CH3 COOH and CH3 COO minus. Now I will add the H plus ion on addition of H plus ion. On addition of H plus ion, once we add the H plus ion, basically this CH3COOH, whatever acetic acid is there, it will dissociate into CH3COO minus and H plus. Once we add the H plus ion, because of the common ion effect, what will happen? Equilibrium will shift toward the left side. So basically, we will form the CH3COOH, which is again like then pH will not change the signature. What will we do the other one? CH3COO minus we have. If we add the H plus ion, what it will form? It will basically form your CH3COH. Again, it is feebly dissociated, right? So feebly dissociated. So hence pH will not change. pH will not change significantly. significantly. Right? Now, what happens if we add the base? On addition of base. Suppose we are adding the OH minus I. Now what will happen? We have this CH3 COOH. If we add the OH minus ion, what will happen? It will form that CH3 COO minus plus water. Now CH3 COO minus is already in the solution, right? And water is again again it is very feebly dissociated. Feebly dissociated, right? So hence this pH will not change. pH will not change significantly, right? So this is the buffer mechanism. Like once we are adding this acid, it is again forming like a CH3OH, which is acetic acid is already there and it is feebly dissociated. What happens if we add the base? It will form the acetate ion, which is already in the solution, and water is again a feebly dissociated solvent. So this can act as a like a buffer salt. Now the question is that if we have a strong acid and a strong base, suppose HCl and NaOH we have. So HCl is a strongly dissociated, so it will form like NaCl plus water. NaCl plus water, right? Basically, it will be like in this form. But once we add the acid, what will happen? Strong acid is there; it will not resist because HCl H plus ion concentration will increase. Once we add the OH minus ion, OH minus concentration will increase. So it will not able to resist the change in the pH, right? So this is the option C. Is the correct answer for the question number. Is it correct? Like everyone got like how the buffer action is there. So the other way like that, if we have big base and its conjugate acid, it will also work as a buffer solution. So people can go and try like ammonium hydroxide and ammonium ion, right? This will act as a buffer, so they can go and practice like what happens if we add the acid, what happens if we add the base, like how pH is registered in this. So basically the buffer solutions are the weak acid and its conjugate base, or we can say that weak acid in its salt and our weak base in its salt. So basically ammonium hydroxide and ammonium chloride will be the uh, uh, like buffer solution for this. Uh, but basically, this big base and its salt will act as a buffer. So is it clear? Like if question is given in the like somewhere in examination, you can easily find out, or you remember like a big acid and its conjugate base, or big base and its conjugate acid can act as a buffer, right? So the answer is the uh, option C. Correct? Okay. So now question C is the what is the effect of solvent and the property of acid and bases is called. Can anyone tell like for the question number 3? Okay. So they are saying the leveling effect. Yeah. So basically in the last class I have told about the leveling solvent. Leveling solvent. So this again in the last class I have already explained what are the leveling solvent. Why like suppose if we have water, if we put any acid, it will form the hydronium ion and it will levelize the acid. So if water, if we put acid base, what will happen? It will form the uh, like OH minus hydroxide ion, and it will label as a base, like label the base. So basically this is a very easy case question. Like in the last class I have already like explained what are the labeling as solvent. So this I think don't need more explanation. So what is the labeling solvent? So next question are more important. So in a buffer solution, an addition of a small amount of strong acid or base, pH will increase or decrease, or C remain nearly constant, or none of the above. Anyone? Anyone can tell what is the answer for the question number 4? Yeah, Shweta is saying C. Yeah, Surya is also saying C. Okay, so great. So first one we have seen that this one we have already seen. Like first, what is the buffer? Buffer is basically a weak acid and its conjugate base, or weak base and its conjugate acid. So in this, I will explain like how this pH will remain nearly constant for the buffer solution. So first I already told you the weak acid and its conjugate base, it will be the pH will remain nearly constant. Now I will take that other option. Suppose we have taken a weak base and it conjugate acid, or we can say that and its salt. Any of is fine. So I will take the example of ammonium hydroxide and ammonium chloride. Now what will happen on addition of H plus ion? What will happen? So basically ammonium hydroxide plus H plus ion, it will give ammonium ion plus water molecule, right? So if we add, like if we write H plus as a HCl, so what will form here? Ammonium chloride, which is a salt. So this will not change the pH of the solution. Water is again a solvent and it is feebly dissociated, right? So it will also not change the pH much. Now what will happen on the addition of the base? On addition of base base like OH minus, right? So suppose we have this ammonium hydroxide. If we add OH minus ion, right, equilibrium will shift toward the left because it will form ammonium ion plus, because of the common ion effect. Common ion effect, right? So common, because of the common ion effect, equilibrium will shift towards left and it will be remain as the ammonium hydroxide. What will happen to the ammonium plus ion? It will take OH minus and it will form again the ammonium hydroxide, which is again it's a feebly dissociated. So the pH will not change much. So here the idea is that what's happened in the addition of acid and the base. So we can see that if we are adding H plus and OH minus, the pH is not changing, because here that more or less we are the whatever equilibrium we are seeing, either it is going towards a compound which is feebly dissociated, which will not change the pH of the solution. So this is clear. And one more concept is there here, the buffer capacity, like how much acid or base it can absorb without significant change in the pH of the buffer. So that is the, again you can see that what is the buffer capacity and buffer index. These things you can go and check, like what are the things, but basic idea is this. Okay, is it clear, the question number 4? Anyone can write in the chat box. Okay. Thank you. Now the question is that which indicator among the following can be used for the pH range 4.0 to 4.3? Anyone? Phenolphthalein or methyl red or thymolphthalein, indigo carbene. Okay. Shweta, Soumyadeep or Ashwat. Okay. Okay. Ashwat Krishna is saying A. Okay. Uh, here Ashwat has come up with a different answer than Sweta and Soumyadeep. So, okay. Sweta and Soumyadeep can tell why particularly methyl red, like how you find out that methyl red will be used for the indicator for the pH range 4 to 4.3. Any concept which you have come across? What is the key thing you see first to decide the indicator in what range it is going to be used? The color change occur at that range. Okay, okay, that's fine because yeah, definitely then that's why we are going to use. But what is the reason why the color change happen at that range only? Right? Anyone? Okay, so let's see. Suppose like you went and wanted to start one experiment like acid-base titration. You are going to do like uh, weak acid and strong base titration. So basically, it's a weak acid and strong, sorry, strong acid and weak base titration. Right? So, okay, Ashwat Krishna reactant will be used. Okay, that's fine. But the concept behind is that you have to see the pK value of the indicator. pK value of the indicator. So once you go to the lab, you wanted to do an like acid-based titration. You wanted to first you decide what kind of curve it look like. So in the subsequent question, I will come with what are the all different four types of titration is there, like weak acid, weak base, strong acid, strong base, weak acid, strong base, and weak base, strong acid, like that. Whatever all combination will come, I will come through that. But here the important thing is that pK value. So this pK I have taken from the Google. So this is 9.3. This is 4.8, or you can think professor has given 5.1, so it's okay, just for the simplicity. This is 9.2, and this they have given the range 11.5 to 14. So I'm expecting that pK is will be close to 12, right? So now we people knows that Henderson equation, right? So I will just show you. So Henderson equation is what? pH is equal to pKa plus log In minus concentration, sorry, divide by concentration of HIN. So here In minus is the indicator in the ionized form and HIN is the unionized form, right? So what happens when In by HIN is 1 by 10. 1 by 10 means 10% is the 10% is ionized form and 90% is the unionized. So this is pH is equal to pKa plus log 1 by 10 means basically pKa minus 1. So what happens when other way, like one is the 90%, other is the 10%. So IN minus divided by HIN is close to 10 by 1. So IN minus is uh, 10 times than the one, means 90% is IN minus and 10%. So what will be the pH is pK plus log 10. So basically it's a 1, pK plus 1, right? So you can see that first we see the pK. So in pK, if we are going to 1 unit of the pH above, we are seeing the different file. If we are going to 1 unit below, that is the another file. So what is the indicator is? Indicator has two different color. One is the neutral condition and other is the ionized, or you can say that ionized far color or unionized far color. They have two different color, right? So suppose if you are who has said this, Ashwit Krishna saying that phenolphthalein. Now phenolphthalein is having this 9.3. So if we go above 9.3, suppose somewhere this 10.2, or if we go below 8.2. So 9.3, below 9.3, below 8.2, it has one color, and the above 9.3, it has a different color. Now if the your endpoint in the in between region of 4.2 to 4.3, so that will be the always the 8.2, the pH is higher, so it will be always in the one farm only. It will never go to the other farm. Am I right? So it will be always in the this acid solution. So your phenolphthalein will be the colorless. It will not change the color in the range of 4.0 to 4.3, because phenolphthalein will only change the color if your pH will change from 8.2 to 10.2, right? So you need such a titration where pH will jump from 8.2 to 10.2. So this is the phenolphthalein is not the option. Now this thymolphthalein is also not the good option. This indigo carmine is also not a good option. But this methyl red is the correct option, because your pH, your endpoint is coming 4.0 to 4.3. So this 4.8 plus minus 1, it will be around like if you give plus minus zero point 0.5 also, it will be some 4.0. You can write 4.0 to close to 6, right? It will easily change the color from one solution to the other solution. So methyl red, it is in the red in the acid solution and yellow in the base solution. So if you are titrating with base, so from the endpoint it will easily go to the base. The base will be the pH will immediately jump from more than 6. So that is the way you are going to find out how what indicator we can use. So you have to see the pH, you have to look at the Henderson equation and find out like which is the suitable indicator. So professor has already taken one lecture on that. So one more question is there. In that I will show you that what is the pH range, why we are you going to use this indicator. Is it correct? Like everyone is okay with this kind of explanation? Ashwat Krishna is saying okay, sir. Yeah. Okay. So this is the way we have to find out the. Now, what is the color of phenolphthalein in the basic medium? Anyone, like it's a BSc question, like in the if anyone has done the acid base titration like SCl and uh, ACl and this one sodium hydroxide titration, they have seen that the what is the answer for this? Okay, okay. Most of the is current is the color is the pink. Now, basically here I will explain in detail why the color is there, why colorless and pink is coming, what are the reason behind this. Okay, so basically, suppose I am writing this phenolphthalein as a HPH, right? So if anyone has gone through that theory, there are two theory. One is the Ostwald theory, and other is the bentonite and quinine theory. So basically, quinine theory, right? So so what is the Ostwald theory saying? Like basically, professor has always also said that indicator are big organic acid or base, right? So your indicator is basically either weak organic acid or weak organic base. So HPS is the weak organic acid, weak organic acid. Once I will write the structure, you will know, right? So its structure is basically you have this phthalic anhydride. So first I will write the phthalic anhydride. So basically your phthalic anhydride is like this. Okay. Oh, 1 minute. Sorry. Sorry, sir. This is not the how to delete this. Okay, let me write once again. So I will write it like this. Phenolphthalein OH C. 1 minute. I will just turn my computer and delete that. Okay, not in this, so I will just try. Okay, we have OH here. Okay, so this is your phenolphthalein. Now it has two far. Basically, your indicator is HPH, so it has two equilibria. It will go to the H plus pH minus. Right? Now, what happens if we add the acid? If we add the acid, what will happen? The equilibrium will shift toward the left. So on acid, what will happen? Equilibrium shift toward the left because of the common ion effect. Common ion effect. Because we know that if we put the strong electrolytes, basically what will happen? The weak electrolyte will dissociation will suppress. So this pair will be stable and it will be in the more quantity. So basically this is the colorless. So we can see that in acidic condition, phenolphthalein is basically the colorless. What will happen if we add the base? In the base OH minus, what will happen? Your pH will basically go to the pH minus. Here OH minus is there plus water. Now this anion is basically the color, which is the pink color. Now you will ask the question why it is pink color. That other theory is there, that is quinine theory. So what will happen basically? Your OH is there, so your base is here. It's a nucleophile. It will take the proton. This bond will come here. This bond will come here. This will come here, and this will uh, break. So what it will form finally? It will have benzene. Sorry, this is OH, and then we have C. We have here quinoid form. So we have O. We have here COO minus. So this is the benzenoid form. This is the quinoid form. right? So here we have more double bond and it has that specific color absorption and the complementary color is your pink. That's why it is in basic medium, it is the pink color. So now you can see that what is the Ostwald theory and what is the model Cunard theory. So professor has already told you all this. So now everything is clear about phenolphthalein. Anyone? Yeah, that's what is saying yes. Okay, thank you. So this is the way you have to know the Cunard theory and the Ostwald theory. So you can easily know that like what will be the color in acid and base. Now question number 7. So this is question number 6. Now question number 7. Here is there. What kind of titration curve is the following? It's a strong acid or a strong base. A strong acid versus weak base, or weak acid versus strong base, and weak acid versus. So all four types of combinations is there. So anyone can tell the answer for this question number 7. Which option is correct? A, B, or C, or D? Okay, Surya is saying D. Surya, can you tell me why the answer D is correct? Is there any indicator for this car? Or you can write just, is there any indicator for this? Yes or no? And if you can write why this is the big acid versus big base, on what basis you are saying? Anyone? Just they can say that is there any indicator for this? They can write yes or no, and why this is the only. Okay, let me explain why the option D is correct. What is the curve for A and B? And so first we have this pH, and here we have a volume of the acid 88. 88. So now if I ask what will be this, so I will write here that this is the midpoint is 7, here it is 14 somewhere, and this is the. If I ask what is the pH for the strong base, because it's a strong base, so that pH will be close to 12 to 14. So it will start from here, right? So once that base is there, the pH will change. pH will change slowly upon addition of the acid, right? So this pH will change slowly, right? It will come. Now, once it is neutralized, it will come close to 7 in the neutral one. And once we add the excess acid, that will be the pH of the acid. And for a strong acid, the pH will be close to 1 or 2. Right? So this is the first curve for the pH versus volume of acid added. So here is the equivalent point. Equivalent point. Right? So this is the strong acid versus strong base. Strong base. That is the first curve. Now I will check this is A. Now go to the B. Now it's saying the weak base versus strong acid. So here volume of the acid added. So here we have the again 14 7 0. Now the peak base, what will be the pK? it will be close to 8 or 9. It will start from somewhere here, right? 8 or 9. So once that end point will happen, then it will come to close to 7, and immediately, because it's a strong acid, once after in point, the pH will go down and it will come to the pH of the strong acid, like close to 1 or 0. This is the B. Now C, it's saying the weak acid versus strong base. So again the things will go reverse. 7, 14. Here is the volume of the acid, right? So pH will start from the 13, 12 to 14. It will come to the 7. Now weak acid you consider as the acetic acid, that pKa is 4.74. So it will be go to close to the 4, and it will be like this. This is the option C. And option D is here because it is starting close to 8, right? And it will immediately, this is the pH, where is the equivalent point, close to 7, and then again it is not going 1 or 2, it is going more or less 4 or 5 or 6, right? So this is the pH for the weak acid. So that is the option number C, why this is the correct. Now if I ask what is the indicator you are going to use for the option A, so option is the strong acid and strong base. You can use that phenolphthalein here very easily, because phenolphthalein will change the color from around 10 point. I have written that range somewhere 10.2 to 8.2. So you see that in the basic condition it is pink. Once that acid condition is there, it will immediately go to the colorless. So here we can use the phenolphthalein. It is the option B is strong acid versus weak base. You can use the methyl rate. I have already told, because this will change is happening here in the range of 4, this one, because below that near to methyl rate will be have different color. Above here the methyl red will have the different. So you can have the methyl red or methyl orange. For this, you can again use the phenolphthalein. We have seen that for acetic acid and sodium hydroxide titration, we are using the phenolphthalein because of this color. But for this, there is no such indicator, because the region where the pH range is there, but that is very small. So we don't have such indicator for the weak acid. Is it clear? Anyone can write, like you have got idea how that curve will look like, either like acid based titration. Anyone? Surya, is it clear? Okay, Ashwati is saying yes. Oh, that's great. So this is the way you have to approach the problem. Now question is that which of the following way titrazine can be used in? So sanitizer, food coloring, vehicle, and none of them. So anyone is there, like who can tell which option is correct for question number 8? Anyone has seen the lecture number, which one? 20? If they have seen that lecture number 20, they can easily tell me. Okay, so Medibur is saying. Okay, that's great. So others can see first what is the strategy. So I am writing the this uh, uh, structure from the like professor's lecture only, right? So the idea is to show what is the concept behind this. Here we have NA. So this because you have seen the lecture already. So people why are using this in the food coloring industry, like food industry they are using as a coloring agent. What is the reason behind this? The reason behind is that this azo group, right? This azo group, if you have seen that methyl red and methyl orange, there you will see that like what are the I think next question will be the same why that what is the color for the methyl red. So there I will tell you this thing. So the thing is that here we have lone pair, we have sigma bond, we have pi bond. So the transition we have to see what are the electronic transition is happening for this color change, right? So this I think sigma to pi star transition is the mainly the region for the color in the this compound. So we have to assign the transition. So there whether it is sigma to sigma star, sigma to pi star, which is very weak, or pi to pi star. So like that, you have to find out what is the main electronic transition which is responsible for the color. So if you have suppose one two energy label, so this is suppose one like pi to pi star. I am taking the simple example. So it is absorbing this light. So it is going from the electronically excited state. So it will absorb this light and complementary color will emit, which can see through our eye, right? So this is where you can see. So this is the concept in this question. It is like this. Minute. Now this is question number 9. So what is the color of methyl orange in the basic? Anyone who can tell the what is the color of methyl orange in the basic medium? Okay, Aswat Krishna is saying A, yellow. Okay, so yeah, he is right. So basically, you have to see that both the theory, like I will explain through the both the theory, the Ostwald theory and Benjamin-Conrad theory. So suppose, so first is that I already told you that whatever this uh, uh, indicators are there, they are weak organic acid or weak organic base. So this is weak organic base. So first thing is that weak organic base. So this is MEOH. So we have to see. So basically it has equilibrium with Me plus OH minus. Now this has one color and this is has different color, right? So this color, this MEOH color, which is like unionized, which is yellow, and this is red. Now we have to find out like in acid medium, in basic medium, which will be the uh, farm will be available. Am I correct or wrong? Okay. Okay. So this is the methyl orange. So I will write the structure of methyl orange quickly. So this is again an azo compound, double bond N. So methyl orange and methyl red both are more or less similar. So if you put here COH, that will be the your methyl rate. And if you put this on fourth position, sodium salt of sulfonic acid, so basically it will be the methyl orange. So this is your methyl orange. Methyl orange. Now this MEOH is there. If you put acid H plus, what will happen? It will dissociate as a Me plus and water will form. So in acid condition, basically the ionized form will be there, which is red in the color. What will happen in the base condition? If you put the OH minus ion, the equilibrium will shift toward the left, and right one will be the very small. So this will be the Me plus OH minus. So the equilibrium will shift, and this will be the your compound, which will be the this will the compound present in the is basic medium. So which is your yellow. Now the question is come where this yellow and these things. So this is methyl orange. This ionized form will be the unionized form will be the yellow. Now once we put the acid here H plus, and this side if we put the base OH minus, what will happen basically? This has lone pair, right? It will come here, this will go there, this will come here, and this bond will attack on H plus. So basically you will form this compound SO3 minus Na plus, and here you have NH single bond and double bond quinoate, then double bond N plus this. So this is your uh, red in color, which is in the acidic solution. So I think this will be clear for the methyl orange why the color is in the basic medium is red. Correct? Oh, sorry, yellow. Red in the acid medium. So this is the way you can just know what is the ionized farm color, unionized farm color. So in which condition, whether ionized farm or unionized farm, it can be asked in any way question like what is the color. Just you have to know that whether it is weak organic acid or weak organic base, what is the reason for the color, you can see that like how it is happening. Okay, if base is there, it will take the proton, it will again the this bond will come here, this will open up, and easily it will go to form in the this neutral form. Now the last question is that which ion among the following is detected by using the reagent called 110 phenanthrolene? Anyone can tell me what is the answer for this question number 10? Oh, Shweta is saying A. Okay, so I will tell you this answer with one analytical application also. This question is very important because it has very significant in the analytical chemistry. Okay, Sweta is also saying A. Yeah, that's great. The question is the answer is A. So first is phenanthrylene. What is that? It's a basically here it's a benzene. And then we have another benzene, and here we have another benzene like that. And these two positions have nitrogen. All right. So this is the bidentate ligand, means two sides for the coordination. Bidentate ligand. Now this iron 2 plus will form a complex. Basically, it will form is if I say phenanthrylene co, if I give the name, you can write it like same way. So this ligand I will give this name something L. So this will form Fe2 plus L3. So it will be like Fe L3 2 plus. So it will be like this Fe. So this two side will be N. So this is one ligand. So will be two side. This other ligand. And that. So this is the very important because it's called ferroin. ferroin complex, and it is your wine red, or somewhere it is written, I think, yeah, it's a wine red color, right? So this you have seen in the last lecture, where the, like, if you want to detect iron, so basically the iron will be in some form. You have to use the acid treatment or base treatment to get the iron 2 plus form, and then you can easily find out this complex, which is the ferroin complex. So similarly for aluminum we have oxygen. Oxygen is nothing but it's called 110 phenanthroline. So it's like this NOH. So here we have this. So for aluminum, this is the again an important complex where we can easily detect the aluminum. How to detect the aluminum for oxide? So this is for aluminum oxide 3. This is the very important complex also in the analytical chemistry. How to determine the aluminum 2 plus. Now this ferroin is also a very important internal standard, or you can sorry, internal indicator. So how it will use as an internal indicator, I will just explain. It is not like important here, but for your knowledge purpose you have to know that how it work as the internal standard, this ferroin complex. So basically suppose you have this arsenic. I have already told this is a AS2O3, uh, and AS2O5, we saw that in the deer kidney story, AS2O5. So if we put this AS2O3 in water and base, basically here we will get HASO3 double minus. This complex will form. And then we give the H plus, basically we form it H3ASO3. Now, if we do the redox titration, so in the redox titration, what are the reaction? This is basically AS3O3 minus plus water. It will go right. So basically, it will form ASO4 minus 3 minus plus 2H plus 2 electron. And now we know that the cerium is very important uh, standardization solution. So basically we have cerium 4 plus electron. It will go to the cerium 3 plus. So if you write 2, so basically it will be the balance one. Now suppose, now if I want to know that whether this redox reaction is complete or not. So what will happen? We just put this ferroin one drop in this the solution. So what will happen? Once that R reaction will consume, what will do the cerium? Cerium will basically next your will oxidize the ferroin complex. So basically ferroin 2 plus, which is ferroin. So I will write ferroin. Ferroin means Fe3 plus L3 will go to the ferrin, which is the Fe3 plus complex, which option is there also, right? Fe3 plus complex, it's a deep blue color, deep blue color. So this is how people used to get as an internal indicator for the redox titration in this. So this is very important complex, this iron 2 110 ferrothrulin complex, which is called ferroin, and it has an application called internal indicator used in the redox titration. So wherever redox titration is there, you just put one drop is there. So once redox titration is complete, the next one will be the ferroin will go to the ferrin, and you can see the corresponding. So I think this is the last question. So this, if anyone has any doubt, they can ask, or I will close the meeting now. So is it clear for all the question? I will upload this slide. I have just taken what are the concepts is there. You can I will upload this slide into the Google Drive. So anyone has not seen that video, they can go through this PPT, and all are the their concepts is there. So if you can go through that concepts. Okay. So I will stop the meeting now, and thank you for joining. Okay. Yes.